All right, this one is called Flower Power because we're trying to create a garden. And I really like this one because it requires you to remember a few things from middle school about the perimeter. Because what we're doing is we're designing a rectangular garden, right? And there's a fence going all the way around it. And as soon as you read that word, your brain needs to start thinking, hey, that's called the perimeter of a rectangle, right? The perimeter. So we know that x is going to be the width of our garden and y is going to be the length. Well, the first thing we know about it is that we have to use no more than 80 feet of fencing. All we have is 80 feet of fencing. So think about that. That's the entire perimeter of my garden. We have 80 feet that has to go all the way around. So remember, think about perimeter is. Perimeter is not just one width and one length, it's actually two of them. So there's two widths, aka 2x, plus there's two lengths, 2y. And in this case, we have 80 feet in all. So we've got to be less than or equal to the 80 feet that we have available to us, right? From there, it's not too hard. We can find those x and y intercepts real fast, divide by 2 on both of them. So 40, 0. And this actually doesn't make any sense, right? Because we could make a garden that was 40 feet wide, but it wouldn't be anything long. That would be a terrible garden. Or 40 feet long and not be any feet wide. So that doesn't make any sense, really, truth be told. We don't want a super, super, super skinny garden or a super, super. So that's why these other two inequalities come into play. And they're a little bit more undercover because you read them pretty quickly. It says, well, he wants the width to be at least 5 feet. And you kind of just go over that real fast. But being the width being at least 5 feet is actually an inequality. Because what do we know? We know that the width is x. So if the width is x and it has to be at least 5 feet, then that means it has to be greater than or equal to 5. So it's not a really complex inequality. It's just a very basic one, but it's really, really powerful. Same idea goes for the next one. The next one, the length has to be at least 20 feet, right? So that means that y, my length, has to be greater than or equal to 20, right? So we actually now have three inequalities, and we could graph all of those. So that's exactly what I did already here in Desmos. So if we type in our first one, second one, third one, you get this crazy shape, and it might be kind of hard for you to see right now, but you get this red triangle, blue, you see green. So you see this triangle looking thing where they all intersect, where they all overlap with each other. So let me get this on the screen so you can visualize a bit better. So we have this triangle shape, and you can see, I'm going to highlight it here, that basically we can go anywhere from here, anywhere inside this region. Anything in here is good to go, right? So think about that. Let's do a little bit of reading this graph here. If we were to read this graph, we could say a couple different things. We could say, hey, our rectangular garden, if we were right here, could be, I'm not even sure where we're at right there. Let's see, that's 10. So 2, 4, 6, 8, 10. So this is right here at 5. So we could be 5 feet wide and 20 feet long. That's what our garden could be. Or going all the way up here to the top, we could be 5 feet wide, but 35 feet long, right? Or somewhere over here, we could be, looks like 20 feet long and 20 feet wide. So you have all these different combinations, and as well, anything on here, anything on that line is a possibility as well. So that kind of brings us to the end of our rectangular garden, making sure that we can visualize what are the different possible combinations of widths and lengths. One last one now.